Alrighty, folks, it's time to get into some logarithmic functions. This is going to be great. I'm so excited. Alright, so we've got exponential form and we got logarithmic form. Basically, logs are there to help us solve for exponents. So if we're looking to solve for an exponent of some kind, we can use logs to get there. So if it's in exponential form, but you're trying to find this, you can rearrange it into log form, and now it equals x. Whenever you have like log base a number of a number, the answer is just a number. It's really just a number. Don't be all freaked out by the logs. So log base 6 of 36 is just 2, because 6 to the second power is 36. Okay, so what we're going to do is a little bit of rearranging from exponential to logarithmic form and vice versa. All right? And the way I like to do that is with what I call the loop and swoop method. Ho, 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 ho. All right, so to go from exponential form to log form, it's going to be log base b of y equals x. So log base b, because that was the first one, right, of y, that's the second one, equals x, because that's the third one, which is basically what we have right here as well. It's just flipped around. Awesome. And you can go back the other way as well. I would have b raised to the x equals y if I wanted to go back to exponential. So if I'm in log form and I want to go to exponential, or exponential to go to log form, that's how I would end up rearranging things. So what we're going to do right now is rearrange. All right, so I've got 5. So log base 5 of 125 equals 3. Log base 5 of 125 equals 3. And remember what that's saying is 5 to the third power equals 125. I use logs to figure out exponents. Alrighty. Why don't we try this other one over here? Now for this one, since the log is at the end, I'm going to have to go backwards. So I'm going to have 6 raised to the third equals 216. And again, it's because I start with the 6, that's my first one. Then the second one I come across is the 3, so I put that in the exponent, equals 216. Awesome. Why don't you try the other two, pause in the video, and hit play when you're ready. Alright, these next ones. So I have log base 4 of 1 over 64 equals negative 3. So log base 4 of 1 over 64 equals negative 3. Cool. And the other one, 2 raised to the negative 4th equals 1 over 16. 2 raised to the negative 4th equals 1 over 16. And keep in mind, we know this is true. 2 to the 4th is 16, so 2 to the negative 4th is 1 over 16. Right, so we know that's correct. Alright, so what we're going to do is a little bit of no-calc action, no calculator. We'll learn how to do this with the calculator later, but it's helpful to be able to know how to do both, because we will have calc and non-calc parts of our exams. So it says, what's the value of log base 2 of 32? Well, keep in mind, you're trying to think of like 2 to what power gives you 32, so you could rewrite it in exponential form. So 2 to the, and pretend you're setting this equal to x, so 2 raised to the x equals 32. Okay, well, maybe we could figure something out here now. Well, what if I were to change 32 into something like 2 to a power? So 2 to what power equals 32? Well, that would be 5. So now what I have is 2 to the 5th equals 2 to the x. Now, since we have the same bases, meaning both 2 and 2, I can now get x equals 5. I can set those exponents equal to each other. Oh, man. That's awesome. So if we have the same bases, our exponents have to be the same in order for the equation to be equal on both sides. So now let's evaluate each log. No calculator. See if you can handle these, and hit play when you're ready for an explanation. Alright, the first one. If we write it like what we were doing before, we can think, okay, well, I would have 2 to the x equals 16, and then I could rewrite this as 2 to the x equals 2 to the 4th would give me 16, so 2 to the 4th, 2 times 2 times 2 times 2 gives me 16, so that means that x equals 4. So our answer is 4 when we evaluate the logarithm. You can also think to yourself, 2 to what power gives me 16, and that's your answer. Let's use that idea here. 3 to what power gives me 9? Well, 3 to the second power gives me 9. There's my answer. That's it. How about the next one? 2 to the 1/8. Well, 2 to what power gives me 8? 2 to the third. So that means that 2 to the negative third would give me 1/8. So really, -3 is my answer. And lastly, I have log base 8 of 32. 8 to what power? I don't know about that one. This case here, I wouldn't actually be able to do this without a calculator. Okay, so this particular one we can't really do without a calculator. We will learn later how to do this particular one with a calculator. What if I just had like log base 8 of 64? Let's say that, because that one will actually work. Well, 8 to what power gives me 64? 2. Sweet. Nice job, guys. Now here we got some special cases. We have log base 3 of 3. So really you're thinking 3 to what power gives me 3? That's what we're thinking there if we set that equal to x. So 3 to the x equals 3. So 3 to what power gives me 3? Well, that would be a 1 really there, so it's x equals 1. So 1's my answer. 3 to the first power gives me 3. How about log base 5 of 1? Well, 5 to what power is going to give me 1? Well, anytime an exponent is 0, I get 1. 100 to the 0, 2 to the 0, 1,000,000 to the 0 power always gives me 1. So that means my exponent is 0. This one over here, log of 100. Fun fact, if you don't see a base, like you did here with the 3, right, or here with the 5, so the 3 is a base there, the 5 is a base there, if there's no base written, it's automatically 10. So it's log base 10. So we're thinking 10 to what power gives me 100? Well, 10 squared would give me 100, so my answer is 2. Cool.